Bill, you want to mute your button there?
Okay, we're on lesson 33. If you can't see the slide, let me know. If you don't respond, I'll assume you're seeing it. It's our 33rd lesson. We're still in chapter 9 of the book, and we'll be looking at a link here. This is a link on what's called what we're dealing with is antipodes. And antipodes will explain what they are, and it'll help us to understand some geologic formations that are on the earth. Now, remember, as we laid this out last week and the week before as well, there are craters in the earth and craters that are filled with sedimentary rock, and then more craters above that. There's 3 basic rings of craters around the earth, and that fits our my model of the flood being caused by a planet with rings, and that the rings impacted the earth and formed the craters. And we're going to see what happens when craters hit the earth. Basically, in simple terms, for every action, there's an equal and opposite or corresponding reaction. And what we have here is, if we have an impact, like on the top here, then the core of the earth is more dense, and the forces of this impact will move through the magma off the sides of the earth and impact and create an antipode on the opposite side of the earth. Now, this model here, the early models were simulations of it based upon assumption the earth was spherical, and they had to correct them because the antipodes weren't exactly in the right spot. But what happens when an impact occurs on the earth, the opposite side of the earth has the forces pushing upward on it. And this probably explains what we call seamounts, Seamounts, seamounts that are in the Pacific Ocean. Particularly, there's a bunch there. These seamounts correspond to their antipodes for impact craters on the other side of the earth. And probably a bunch of volcanoes actually occurred from impact craters. So these forces now would go across through the earth, through the magma, and then be imposed as an upward force. A downward force on top here would then move through, be an upward force on the other side, and that would explain some of your seamounts. You can type seamounts and find diagrams of them, and seafloor maps would show them in the oceans. Now, here's another one. This is another antipode source, and this, of course, is spherical, and so they had to correct it. Here's one on Mars, the impact crater, and so we see the impact, and then the other side of Mars, and the other side we see the antipode from it. So we have both through the center of Mars. And the impact, of course, goes directly through and has a welling up on the other side. It comes out the center of Alba, the largest volcano on Mars. It created a volcano. And so this is understood. This is, there's good physics behind it. The physics is definitely good, and there's no reason to question the physics. I don't believe. So this created a lot of lava on Mars. This is what they think occurred. I think they're probably correct. Now, we do have here the inner planets, and of course, Mercury, Venus, Earth, and Mars. Then there's an asteroid belt that some think may have been a planet that was fragmented somehow. And the Trojan asteroids out here that fit in with Jupiter. Now, these asteroids are locked into an orbit with Jupiter, and they orbit around in the same orbit as Jupiter. Now, Jupiter is a big planet, the biggest of all our planets, and it actually is a source of light. It gives off more light than it's not just a reflector, it actually has a source of energy. And that's another matter we're going to discuss later. But the asteroid belt is in here, and these asteroids, some of them move across through our path. We have some that cross the path of the Earth. But I think some of the so-called asteroids may have been from something else, okay? May have been part of the rings or part of Mercury as it created the flood. Now, the hole at the bottom of the moon, there's a hole at the bottom of the moon, and this is from the magazine Nature. It's a high-quality scientific magazine published in England, volume 453, pages 1160 through 1163. And this is the south pole of the moon. The moon hasn't been impacted, and it has also antipodes on it. Here's another source of it, link, and you can go to this link and get more information about it if you like. Now, when we see the seamounts, here's some of the seamounts, diagrams of them, seamounts underneath the ocean. And so we have seamounts. Some of the seamounts actually look well up, almost like a mountain. They look like mountains. This looks like the short mountain range. Could have been several craters all together coming in, and they could have uplifted this very easily. These seamounts definitely are linked with antipodes. And here's an updated model out of Princeton University that shows the fallout from giant meteorite strikes where they get antipodes for us. Now, this model here is modeled after the true shape of the Earth. The Earth is oblate, which means it's fatter at the equator because of the spinning motion than it is at the poles. So it's not not exactly a sphere. It's oblate. It's fatter at the equator. So that oblateness wasn't factored in, but the Princeton model does factor it in. Makes it a little more complicated. The mathematics is more complicated. Early models were based on a spherical planet. They did not take into account the actual shape of the Earth. It's oblate. This model takes into account the actual shape of the Earth, and it gives a better location. It locates the meteorite strikes and the fact that the seamounts and the places where we had volcanoes that have occurred have been actually large from meteorite strikes or large objects that struck the Earth, no doubt during the flood. Okay. Now then, we're going to go away from the seamounts. This fits in. Of course, now remember, these these impact craters are filled with sedimentary rock. Some of them are above, they got sedimentary rock underneath them. Then they fill up with sedimentary rock, and then there's another layer of craters above that. So this had to have occurred during the flood. These craters had to have occurred during the flood. Chesapeake Bay is formed by a crater. And those have to come across and cut through the Cumberland Gap, as we said, I believe in the last lesson. Now, ice, of course, we've set forth how ice came in, but ice did not melt immediately. Of course, this ice was extremely cold, but it affected the Earth's climate drastically changed the climate, forever changed the climate of the Earth. There were bodies of water and there were ice dam lakes. We'll be seeing these ice dam lakes and how they affected the Earth. Now then, the continents are floating, and islands such as Greenland and so forth are floating on magma. The island and the continents have a bottom part like a tooth like a rut on a tooth called a craton, C-R-A-T-O-N, a craton. Now these cratons are thought by scientists to be ancient, according to their dating, their original. They haven't changed. But the cratons afloat in the magma, basically molten rock. It's very thick molten type rock, but it's molten type rock. And so whenever ice or large amounts of water go on them, these bodies will sink into the magma. And of course, hydraulic forces, like a hydraulic fluid, it would provide forces throughout the whole world. And the magma would be compressed, and it would just like a hydraulic jack. Their bodies of water. Now this ice and this water that's on the earth, even after the flood and these lakes that were formed from it, they would cause the continents to sink into the magma, and that's called isostasy. That is, they would sink and they would stabilize. It's like putting a weight in a boat. It'll sink down in the water a bit. That's exactly what we see, the same basic principle. And of course, now then, once this ice begins to melt off, these continents then will uplift, and that will shift throughout the earth. Of course, when all that occurs, you're going to get shifting in the magma, and you're going to get volcanoes and other earthquakes and other things. I think the volcanoes and earthquakes are just one of the things that we're going to have to live with until the second coming of our Lord. When the ice dams, however, ice dams occurred and formed ice dam lakes. Some were quite large. When the ice dams were breached, that is, the ice melted so that the water could get out, there were no doubt flash floods of giant proportions that occurred, and we'll show evidence of that. Now, here's an ice dam, or a dam. After a lake that's formed, there's also a series of lakes called fluvial lakes that weren't formed by ice. Now, these lakes, like Lake Bonneville and Provo Lake in Utah and Nevada, up into Idaho, these lakes here were quite large. Here's the present Great Salt Lake, and here's Lake Bonneville, which included the Great Salt Lake. There's Logan and Ogden, Utah, and Salt Lake City. These lakes were full of water after the flood, and then the water dried up. To the west of these lakes here, there was the mountains over on the eastern California and western Nevada, the Sierra Nevada mountains, blocking the flow of moisture. When the moist air goes uphill, it gets less dense and it cools off, and so it will rain. The western slopes of the Sierra Nevada are quite wet. They have a lot of moisture. But the eastern slopes, whenever it goes down the eastern side of the Sierra Nevadas, the air gets very dry because the air begins to compress and it absorbs moisture out of the sides, the east side of the mountains, and it goes across Nevada, which is basically a desert, and so it goes across Nevada, and as it goes downhill, it warms up and takes in more moisture. Three factors create rainfall. There has to be sufficient moisture in the air, and if the barometer drops and the temperature drops, and sufficiently, it will rain. The moisture will come out of the air in the form of snow or rain or whatever. Now, what we have then is this area east of the Sierra Nevada mountains then became dry, and these lakes began to dry up. And of course, that moisture then would go up into the clouds and drain and probably go to the east and dump into the Mississippi River. This is probably where it went, or it could have rained in this region around here up to the north and gone out to the Columbia River, okay? But it went back to the ocean. Of course, when it does this weight of this large amount of water then would begin to lift off the continent, off this area, and this would uplift. So this region would rise up a bit. So we'd see a rising of it due to adjustments in isostasy, I-S-O-S-T-A-C-Y, isostasy. Now, Bonneville Lake and Provo Lake are the paleo lakes, the old lakes. Okay, here's also a map of these lakes here, and many of these lakes were not formed by by ice, but they were formed by residual water after the flood. Here's the Lake Lahontan, and it's a very small lake now, I believe, in the state of Nevada. Here's the state of Nevada. Here's California, Utah, and Arizona. And of course, Idaho and Oregon here, and up here is, we'll talk about the scablands a little bit later. This is the state of Washington. There's the state of Montana. We'll be looking at that as well. There's a lake here. This is an ice lake up here, Lake Missoula. And we may have some more ice lakes over here. But this was the lake here, Lake Bonneville, Lake Lahontan. There was another lake down here in California, some more down in this region. Now, there's sufficient evidence of these lakes. There's also a lake over here that they've discovered now in Arizona, which I think may have cut the Grand Canyon very quickly when that lake breached. What would happen here is there'd be low areas where this water would sit. If this water built up sufficiently, it would break through, and this is what happened in Lake Bonneville. So there's a water flow that went down through here and created and cut the Snake River. And there's two flows here that were involved, and we see this occurring, and this occurred here and cut this river very quickly. And so we have flood routes here. This will be your flood routes coming out of these lakes. Okay, and again, there's evidence for that. But my flood model fits it because this is residual water that was there after the flood had ended, because this is a lower area and the water stayed in it, and it had to evaporate, or if it built up sufficiently, it breached the basin where it was setting and began to overflow. And when it did, it starts to cut water. Flowing water can cut a channel pretty quickly, particularly large amounts of water flowing rapidly or quickly. It can cut a deep channel. That's what we see here. Now, here's Lake Bonneville. This is your Snake River here, and the water flowed out of it, cut down through Bear River. It went down this way. Okay, but we also have a former course of the Bear River. It went through here, but this water flowed through here and cut a different channel for the Bear River. Okay, and this Red Rock Pass here. So this is Idaho and Utah. Right here is the Postdiluvian Lakes, Great Basin, and this is your Great Basin right here, all across here. It's kind of a orangish, deep orange color. Pliocene glaciers. There were glaciers there, no doubt, that created during the flood, and lakes that formed here. This is in the state of Utah, Utah over here, and here's state of Nevada. Okay, but Death Valley system also. So these were lakes that were there. They were there after the flood, of course. Now, right here is Lake Bonneville, right here, and then there's up in Missoula, Montana. There's another lake up here. This will be the Missoula Flood. Missoula Flood cut through, and we can see this. We'll get this a little bit later, but near Missoula, Montana. But this water flowed out of Lake Bonneville and cut a channel right through here. Cut this channel going up through here. So it cut a channel and the evidence is there. Now, Lake Missoula was an ice lake. An ice dam formed from a glacier, and the Glacier National Park is in this area. But the glacier is melting, and it's been melting ever since the flood. But right here, we had an ice dam right here, and there's your glacial Lake Missoula. And it was a large lake. This lake, glaciers moved in, caused a big dam and large amounts of water, and then the glacier kept melting, the water built up, and it breached the dam, and it overflowed and cut through, and it just scraped off all of the topsoil from this region. We've got a region called the Scablands. Basically what you have is this rock down to the rock, and there's almost no soil on top of it, the Scablands. They're called Scablands, Scablands. I've never been to the state of Washington. I've been to 44 of the 50 states, and I haven't been to Washington. I would love to go to the Scabland sometime just to see it, but it was from Lake Missoula. Lake Missoula breached and overflowed. Then the ice dam reformed, and then it built up again and breached again. I think it did this 2 or 3, maybe 4 or 5 times. There's evidence of more than one occurrence of it. Finally, the ice melted and the dam and the glacial lake overflowed and went down through the Columbia River to the ocean. Now, the large amounts of water that would flow down through here would lift weight off the North American continent. In this region, we'd get an uplift of it, but we'd also have large amounts of water flowing down, tremendous flash floods that would flow, large flow of water. This cold water then would go into the Pacific Ocean over here and change the climate for a while. So this cold ice, very cold water, would then affect the climate in this area. Okay. Now, what we have here's your Cordilleran Ice Sheet up in Canada. It went down through here, and these are lobes of the ice sheets that went down, and they, of course, would form lakes. Now then, we would get to the coldness, we'd get in the mountainous region, there would be ice, mountain glaciers to form after the flood, and probably some could have even formed during the flood due to the cold in the mountainous regions. Okay. Here is your Cordilleran Ice Sheet and your Laurentide Ice Sheet. And there's this gap between we've already talked about, through which the animals could traverse. Again, I see the providence of God in this. They crossed the Bering Strait, Beringia it was called, came across through this region that was in this little gap between here. They were able to eat and have food for animals to move down. They came down and populated north and then down through here to South America. Of course, some animals probably moved on floating debris and wound up down there as well. And of course, I'm not talking about debris during the flood, but the things that floated like trees and small animals could float. And of course, birds could fly and move there as well. Now, again, here's your Cordilleran Ice Sheet and the Laurentide Ice Sheet. These sheets were formed at different times during the flood with different passes of the planet that caused the flood. Now, as the planet moved down, it uplifted the mountain ranges as it went down. The atheists have no way to explain the elevation of mountains. There's no forces that they can use to explain it, but my flood model with the planet Mercury doing it would provide enough gravitational uplift to uplift the mountains that we see. Now, of course, here's the United States, and this up here is Canada. It was covered with ice at that time. This large amount of ice would make the North American continent to sink in the north side of it and tend to uplift the southern side a bit. But it would sink as the ice melted, then it would uplift again. And Norway, for example, right now, the ice that's melting there is causing an uplift of Norway. Some of their piers are completely out of water now because it's risen due to the ice melting. That's called isostasy, and that will occur. Up here's, of course, Greenland, and there's the state of Alaska in the United States, Cuba down here, and of course, Mexico down here with the mountain ranges. Now, furthermore, the Laurentide Ice Sheet thickness is quite thick. This is in meters. Now, a meter is just a little over a yard. It's 39.37 inches. So some of these ice sheets were 2,500 meters thick. Now, if you do the math on it, just multiply it by 3, you'd have 7,500 feet. And the bull were close to 8,000 feet thick. That's the ice that's right in this region right here, this darker region. So you can see the thickness of them due to the color. But that's your Laurentide Ice Sheet. This, of course, is the Great Lakes in the United States. This is Canada up here, and there's Vancouver, British Columbia over here. Now, then the Earth's gravity is not even, or it's not uniform. The gravitational field has anomalies, and those that have taken Greek will know this is the word equivalent to and it doesn't follow the law that you'd expect. You'd expect the Earth to be somewhat uniform, but it's not. There's regions that have higher gravity than other places. And of course, material that impacted could have been denser or less dense, probably denser than the surface of the Earth, and maybe created these areas of anomalies. Also, the uplift of the continents would stick up and create the anomalies. Now, keep in mind now, the continent has to be less dense than the magma it's floating in. So that's going to affect it as well. And of course, in areas where it's uplifted, like the mountain ranges, it's going to be greater. So the gravitational anomaly. Satellites, when they're going around the Earth, will just go like this. They go up and down. They actually go up and down and follow it. They don't go in a circular rotation around the Earth. And that's some people don't understand. North American glacial lakes, we have Lake Columbia, which is right here. And then we have Lake Missoula, which is a pretty big lake. And it went way across over in here. This is where it went. And so, again, we don't have the outline of the states here, but here's a computer rendering of Glacial Lake Missoula, courtesy of the Oregon Public Broadcasting System. That's a computer rendering of it, what it supposedly looked like from the evidence that they have. And right here now we have these scablands. We have this region where the soil was eroded away due to the floods from Lake Missoula. Now, Lake Bonneville and Lake Missoula both provided sediment. Here's the Missoula sediment and the Bonneville sediment. So the Lake Bonneville supposedly overflowed first before Missoula did, and laid this bottom sediment, and then Missoula came last after it. So we have the sediment from these two places, from these two lakes. Now we have also another glacial lake, Agassiz. Here's Hudson Bay up here. And what we have here is Saskatchewan, and we have Manitoba and Ontario, Canada, parts of the United States here. Now, North Dakota and so forth. Now, right here is the state of Minnesota and Wisconsin. So right here now, this was a lake, and it was a glacial lake. The glacier come down to here, and the water was melted. It was across Hudson Bay area. And so the water melted here and then formed this big lake. Now that's a lot bigger than Lake Superior. It's very large. Now here's a present lake that's still there, a couple of two or three present lakes that are still there now. But here's also some glacial lakes from here, over here in North Dakota and so forth. Now, these lakes then, Agassiz, this lake here, see how much bigger it is than Lake Superior, quite a lot larger. And so the water here, once it melted the ice here, this water would flow into Hudson's Bay. Of course, then it would fill and it would go out into the ocean through Hudson Bay, the Hudson Bay area. Laurentide Ice Sheet then formed this lake. This lake went all the way to Lake Ojibway, and this lake here was down to the area right in here. Now we have the ice. This is a Laurentide Ice Sheet. Still ice here. That's an ice dam here. Once this melts, the water will go back up into Hudson's Bay. Some of the water, however, went down into the Atlantic Ocean through here, and there's a place where it went. We're going to see this as we develop this more fully. But this right here, there's evidence of this, but this will fit our model, no problem with the model. I do question their dating on this, but we won't worry about that. I'll just pull their dates off here. Here's Lake Chicago. Here's your ice sheets as they melted, and they claim 14,000 years ago the ice was over here. And then Lake Algonquin, and it melts backwards. As it melts from the warmer climate coming up and melting the southern side of the ice. 7,000 and 4,000 years ago, they say now we got our lakes here, Lake Superior, Michigan, and so forth. So we have the Ontario River through here as well. There was a river through here. Okay. Now, this is 7,000 years ago. Supposedly it began to fill up some of these lakes here. Okay. Early Lake Ontario here. Right. Lake Erie wasn't joined to Ontario at that time. Right. Again, your Laurentide Ice Sheet that we're looking at. The ice sheet came down into the United States and covered virtually all of Canada. Okay. Now, here's Lake Ontario with the ice sheet. Now, here is the present boundaries of the lake at here. And then this is the ancient boundaries of that lake that formed here. So you get a different, it's larger. And this went down through Lake Oneida, it's called, and it went down through the Mohawk River into New York. The state of New York is on Adirondack Mountains here. So we have this lake here coming down into, there's Rochester, New York, and Buffalo, New York. So it did go down through the rivers here, the Mohawk River and so forth. Now, this, of course, this large amounts of water, once it breached and began to flow, it would cut a channel. And that's what we see here. And what we see is Lake Iroquois, and it cut through the Mohawk River down to Lake Albany. And there's an ice lake here in this region right here for a while. There's the Green Mountains, Adirondack upland. And so that's Lake Iroquois. Now Laurentide Ice Sheet as it melted here. Now this is the river going out, St. Lawrence River going out, but it has covered with ice here. It's not flowing at that time. Well, here's what happened. Oops, I'm sorry. What we have then is this lake here, breached through the Mohawk River, and fill this up. But then as this backs off a little bit, this water here is going to cut a channel, and it cuts all the way down to the Atlantic Ocean, cuts the channel, a deep channel. New York City is a tremendous harbor because it's a deep channel. This channel was cut by large amounts of water flowing very quickly down through it to cut the channel very deep, and deep ships can go up into New York Harbor because of that. Here's the Narrows Dam. There was a dam down here that was breached. What happened is this was material earth, and the near come down, and then it overflowed and cut a channel through this breach. There's a Narrows Dam, it's called. This again, they're dating it with their uniformitarian dating technique, which is flawed, I believe. But what we have here is this is how the river was cut. Hudson River was cut down through here. Okay. Hudson River channel then, if there was a large amounts of ice, the ocean had not filled up as deep as it is now. And so it would cut this channel, this undersea canyon that we see down here. It cut it at that time, probably. Here's your Laurentide Ice Sheets, glacial ice, Glacial Lake Albany. It's called Lake Albany. And it cut through here and created its deep channel, which makes a tremendous harbor for New York City. As we said, there's Long Island right there. Hudson River, either a moraine or an ice dam that impounded Glacial Lake Albany was breached. probably a moraine. Moraine is like where the ice is bulldozed up and made like a dam. But once the water begins to flow over an earthen dam, it'll cut through it pretty quickly. All right. When they make earthen dams for farms and so forth, they try to pack the earth as good as well as they can. Otherwise, it'll seep through and breach it pretty quickly. The rapid flow of water, however, would cut the Hudson River channel very deeply. And of course, as we've already said here, the river was blocked by moraine, which is like the ice as it moved, the glacier as it moved would bulldoze up soil, and then and as far as it went, there would be soil there, would be a big layer of soil bulldozed up, and that's what a moraine is. It's probably called the Narrows in New York City. Moraine. Several hundred feet of the continental shelf was above sea level at that time because the ice was still melting, and the water from the fluvial lakes was evaporating, going into the ocean, like Lake Bonneville and Lake Lahontan and so forth. As we've already set forth, there'll be other lakes throughout the world, other places in the world as well, particularly in places like Russia and so forth. Several hundred feet then, there was an extensive amounts of Hudson Bay submarine canyon was cut. We've already said that. It's immediately lowered the temperature of the Gulf Stream because this vast amount of cold water went out into the Gulf Stream, but it's not just cold water. It's not salt water, so it's less dense. It'll float on top until it mixes. So it may take several years to mix with the salt water. So this cold fresh water would be on top, and that, of course, the wind would blow across and bring cold air into Europe. So Europe would experience a cold region, cold time. Within a few months, the temperature of Europe was probably greatly lowered by this vast amount of water that went into the Gulf Stream. Here's your Hudson Valley Undersea Canyon that was probably cut at that time, and as it flowed down. This canyon could have been cut during the flood itself, but I think it may have been cut after the flood. Here's a picture in the Gulf of Alaska. I picked it up off the internet. It's a glacial freshwater and oceanic saltwater. You can see them right there. That's just a picture of it. Someone flying over took it. That's pretty cool. Now, here's the chlorophyll from Plankton in the Gulf of Alaska. What's very interesting about this is this will show you basically the temperature of the water, how the water temperature is different. That's what we're trying to show here. And of course, plankton is food for a lot of other animals, okay? And for a lot of animals. Here's the state of Florida down here. Here's the Gulf Stream. That's your temperature of your water in the Gulf Stream, the present Gulf Stream. And of course, this is warmer water. This is cooler water up here. And this warmer water flows up and goes across, and then it will go into the North Atlantic and then come south. So right here, the Gulf Stream moves up and goes out here, and it comes down here. Now here is Europe right here, and this will be part of this. There's Gibraltar, Strait of Gibraltar in Africa. So this warmer water goes to the south and warms up the west coast of Europe. Now, if you look at England, here's England right here. England right at that, Spain, France, England, Ireland over here. What we have here, there's Iceland up here. But this warm water then warms up this west coast. But I want you to look here. London, England is about as far north as the southern end of Hudson's Bay in Canada. But it's quite a lot warmer than Hudson's Bay because of the Gulf Stream cooling it. But if this Gulf Stream for a period of time got real cold due to this vast amount of cold water for maybe a year or two, it would have created some havoc over in this region here. But there's the Greenland up there, of course. So now Here's Glacial Lake Iroquois, and there's present Lake Ontario. And so this flooded down through here, the Hudson River, and cut the channel. Okay. Here's our present Great Lakes that are joined here. Now, the weight of these lakes, along with the glacial ice that was supporting the lakes, would depress the continents into magma. This is isostasy. Sudden drainage of these lakes into the oceans, like Bonneville to the Columbia River and the Columbia Lake and the Missoula Lake in the Pacific, Agassiz and Ojibway into the Atlantic via Hudson Bay, would have a cooling effect on these oceans, affecting the climate for a period of time until the water warmed up. Sudden release of the waters of the lakes Bonneville and Columbia and Missoula caused extensive erosion, the so-called scablands that we talked about. The adjustments in isostasy probably caused earthquakes and volcanoes to occur as well. And tsunamis no doubt occurred when this occurred. Large amounts of water going into the ocean could cause tsunamis to occur. Sudden release of large amounts of cold fresh water from these lakes could affect the climate in the northern hemisphere drastically, affected for a period of time. Since fresh water is less dense than salt water, the colder fresh water from melted glaciers would cool the air moving over the oceans and affect climate as this cold air or cooler air went across the continent. This would trigger climate change, trigger climate-related events such as younger dryas, dated about 10,000 years ago by the dating of the atheist, okay? And the old earth creationists would agree with that dating. I believe it's incorrect, however. Here's the younger dryas, named after a flower called the dryas. And this is the flower that it's named after. And this flower was pretty prominent because it can stand, it's a tundra plant. Tundra is a Russian word for describing that area. The dates of the drainage of these lakes are based on two things: radiocarbon dating, which we'll get into later, and barbs, which we'll talk about later. This counting sediment layers of lakes, making assumptions about those sediment layers being deposited one layer per year. This is documented at this website here. You can get more information about it. Again, they've made some assumptions that cannot be proven. Okay. Here's Glen Roy Scotland. My large amount of my family go back to Scotland. I have German and Scottish and English blood mostly in me. But Glen Roy was a glacial lake that caused the shorelines to look like roads around the sides of a mountain. We'll see that in a minute. Be a picture of this lake was not as large as the lakes in the United States. It is a glacial lake, a post-diluvian, post meaning after, diluvian meaning after the flood, post-diluvian lake. Here's the area. Looks like roads up here, but these are areas where the shorelines of the glacial lakes occurred. Glen Roy, Scotland. And so right here, these, you can see them across here as well. And these are the shorelines of the lake. Now, glacial lakes in Patagonia. Patagonia is in the South America. And so we have here Patagonia. Here's Buenos Aires, and so Lago Buenos Aires. And so this is Argentina down here, and probably Chile over to the left side. Okay, the country of Chile. We call it Chile. I think Chile is how they pronounce it, however. But there are lakes there, and there were glacial lakes in Patagonia. In Italy and Switzerland, there's a glacial lake, and I believe it still exists. Like this is a lake that's still there, and it hasn't breached out of the Alps, out of the mountains. Now then, here's the glacial lakes in Russia. Of course, Russia is the largest country in the world in an area. And this glacial lake here there was ice here, creating this lake. This was a large lake. Here's the Volga River. When I was in Russia in 93, 94, and lectured over there, I lectured on the Volga River, and Yaroslavl was where I went. Okay, but it's on the Volga River. But right here, this was a large lake, very, very large. And this is a large area here. Here's the Ob River, and this is in the West Siberian Lake. And again, we have ice dams due to the glaciers, and then the water builds up and melts and overflows, could flow south as well. Now, the Bonneville, Missoula, and similar floods are called outburst lakes, and very interesting occur. They're outbursts of water as it overflows the boundaries, the basin in which it's found. So once it goes over the edge and begins to cut through, it'll cut through the soil pretty quickly unless it's pretty solid rock. Even flowing water can reach through solid rock. It can cut through it as well. Water is very, very abrasive if it's flowing pretty rapidly. There were iceberg lakes when the Siberian lakes were drained as well. So we have them on the Siberian lakes. Outburst lakes have been observed in modern times by glacial ice dams and or moraine soil that's been made into a dam by a glacier. Here's a slide, and it's one that they photographed May the 20th, the year 2002. And there's a glacier, Hubbard Glacier in Alaska, squeezes toward Gibbard Point on May the 20th. The glacier is close to sealing off Russell Fjord from Disenchantment Bay. Second slide, we're going to see it here in just a minute, is this Hubbard Glacier image from July the 16th. The glacier is closed off Russell Fjord from Disenchantment Bay. The waters behind the glacier rose 61 feet, 19 meters in 10 weeks, creating a short-lived Russell Lake. It existed for a while, and then it breached the glacier and began to overflow, cut through it. The third slide we're going to see here in just a moment is the Hubbard Glacier is overwhelmed on August the 14th, 2002, and the second largest GLOF of modern times. That's through glacial overflow, okay? Lake Outburst Flood, GLOF. Okay. A picture of it, Hubbard Bay, as the glacier begins to move across here to close it off. Now it's formed an ice dam here, and there's a moraine from the glacier, and this begins to flow and build up. The water begins to build up in this region up in here. And it breaches on the 14th of August and begins to flow through. They photographed all of this, so these are actual photographs and the dates of it. Pretty interesting. And notice that glacial ice looks kind of blue and kind of a bluish color to it. Very interesting. Now, we have also what are called Heinrich Events, and we'll be looking at those Heinrich Events just a little bit. And were first described by marine geologist Hartmut Heinrich. Occurred during the last glacial period or ice age. During such events, armadas of icebergs broke off from glaciers and traversed the North Atlantic. The icebergs contain rock mass eroded by the glaciers. And as they melted, this matter was dropped into the seafloor as ice-wrapped debris. So the rocks that were in the ice then would, when the ice melted, the rocks would drop to the bottom of the ocean. That's what we see here. That's what they're talking about. Scientists drilling through marine sediments can distinguish 6 distinct events in cores of mud retrieved from the seafloor. So they get these H1 through 6, Heinrich 1 through 6 areas. So we have this ice coming, dropping the stones or rocks, then more ice coming, and this has occurred about 6 times according to this. There's some evidence that H3 and 6 differ from other events, however. there's more information here. Some scientists think Heinrich Events affected the thermohaline circulation patterns of the ocean. That would be the patterns of movement of the water throughout the oceans. That's possible. There's your thermohaline circulation pattern that they see here, but there's been some questioning about this since in recent times about this pattern. Going any further any more into it, but this would affect the climate of the Earth. Some glacial lakes were formed by moraines, of course, earth and rock dams formed when the glacier pushed or bulldozed the soil and rocks into a mound. Well, I think we have a picture of one of those in just a moment. That's glacial. I'm sorry, I got the word misspelled here. It should be a G instead of a C. Lakes were formed by the ice and of the glacier. The next two slides show these mechanisms. So right here we have it here. There's a dam that's been bulldozed up by a glacier. And right here we have an ice dam, Hubbard Ice Dam moraine. There's a moraine here as well, as we showed earlier. It bulldozed up the soil. But it's pretty loose soil. Once, even if it dams the water up, once the water flows over top of it, when the water flows over the top of it, it'll cut through that loose soil real quickly and just can breach right through it. Here's a Moraine Lake. Here's your moraine right here. It's been pushed up and the water fills it up as the glacier and this ice and snow melts. Now, if this doesn't breach the moraine and go over the top of it and cut through it, it may be a lake that lasts for many, many years. Okay. What we're going to do is, as we look at this a moment, I want to know, do you have any questions or comments? Anybody? Okay.